Yes, my dear students, as you know, nowadays COVID-19 problem is going on a lot. How do we save ourselves from it so that we can be safe? First things, wear mask properly. Second, stay at least 6 feet from others. Third, wash your hand frequently. And fourth, remember, don't touch your face, don't shake your hand, and don't share food and water with others. Of this series, suppose sum of the n terms of the natural numbers. Second series, sum of the squares of the natural numbers, n term of the square of the natural numbers. Third, sum of the cubes of the n term of the natural numbers. Like example here, suppose first series here 1 plus 2 plus 3 plus 4 plus 5 plus 6 dash n terms. So what is the result of this n terms here? So this is the, you can say sigma n. How many terms here? This is the value of the sigma n. Then you can say what value of the sigma n? Here value of the sigma n 1 plus 1 upon 2. This is the value of this sigma n. 1 plus 2 plus 3. How many terms here? This is not fixed. This is called the sigma n. A value of the sigma n is n plus 1 upon 2. Second, 1 square of the 1, square of the 2, square of the 3 plus square of the 4 plus dash square of the n. This is the sum of the square of the n term of the natural number. This is sum of the series of the square of the n term of the natural numbers. Then you can say sigma n square means n plus 1 and 2n plus 1 upon 6. This is the value of this. Third identity here, same 1 cube, 2 plus 3 cube, plus 4 cube, plus 5 cube, 1, 2, 3, 4, 5. Every number having the cube here plus dash n cube. What value of this? This is called the sigma n cube. This is when the series of the cube here, this is called the sigma n cube. When series of the square, this is called the sigma n square. When is the series of the simple number, the sigma n. What value of the sigma n cube? N plus 1 upon 2 is the whole square. This is the result of this. The basis of 3 series, on this 3 series, basis of 3 series here, we will solve the question of exercise 9.4. Very important things. Okay, how to solve of the simple natural number, how to solve of the square of natural number, and how to solve the cube of the natural number. This is the special type series. Your GP and AP is the extra of this is the sum of this sum of the AP of next sum of the sigma Sn. What value of the Sn AP? This is the for AP. This is called here n by 2 2a plus n minus 1d. And second series here for GP having the Sn equal to a r exponent n minus 1 upon r minus 1 r greater than 1. Otherwise you can say here ki Sn equal to a 1 minus r exponent n upon 1 minus r when r less than 1. So this is the series of the sum of the series of the GP, the sum of the series of the AP. So you can add these things and note down it first. Yes, student, next question I am taking question number first here from exercise 9.4. Question number 9.4, to find the sum of the n terms. In the given series here 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5. You look this question here, here 1 into 2, don't multiply your 2 1 2, don't multiply your 6, don't multiply your 12. Suppose if you multiply here, then series will be changed. 6 plus 3 to 12 plus 20. So this is not any series. This is not the series here. This is not the natural number series here. This is a 2, 6, 12. This is not AP. This is not JP. So you will not find easily the sum of the series. Yes, first we look this here. This is the not one series, this is the two series here. This one is the two series. First 1, 2, 3, 4 dash dash dash. So what value of the, suppose this is the 1, 2, 3, 4. What is the next and Tn numbers here? Second series here 2, 3, 4, 5, and what is the Tn of this? What is the Tn of this? It means here two series. So you will be split two series here, and then you will find the nth term of this series. First series here 1, 2, 3, 4. Second series here 2, 3, 4, 5. So then you will find the Tn term of this series. Then you will find here Tn term of this series. Then you will find the Tn term of the both the series. So now solution here 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5 plus dash 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 and Tn. So what is the Tn of the first series 1, 2, 3? Then you will Tn term here. Nth term of 1, 2, 3 dash 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 into, the both are multiplier, then you are into the same, and nth term of 2, 3, 4 dash 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 this. So mean what is the Tnth term of the both this series here? The first series here 1, 2, 3, then nth term. Second here 2, 3 starting 2, then here nth term of 2, 3, 4. So now look here. So this is formula of this nth term here Tn. What will be the Tn here? A plus n minus 1d, using this identity here. Using this identity here, so a place here 1, and you don't know n here, n minus 1. What is the value of the d? 1. This is the value of the first. Second here n 2 plus n minus 1. What value of the n? 1. This d. Then you find here 1 plus n minus 1 and 2 plus n minus 1. So you can say to 1, this will be cancelled here, n, or this will be n minus n plus 1. So this is the series of the sigma n. It means you can say the n square plus n. The value of the Tn here, what value of the Tn? The n into n square, and n plus 1 is 1. So according this way, every question you will solve. To first will what is the value of the Tn here? What is the value of the Tn? First of all, solve this. After then you will solve the sum of the n terms. After that you will find here the sum of the n terms. First you will find the how many terms here? N. Then you will find the sum of this. So now sigma Tn equal, what value of sigma Tn? N square plus n. After that you will write here sigma n square plus sigma n. Doing separate this as sigma n square plus sigma n. Or you know sigma n square value of the n plus 1 and 2n plus 1 upon 6. Or value of the sigma n plus 1 upon 2. This is the identity of sigma n square, or this one the identity of this sigma n. You take the common here, n plus 1 you take common upon 2, and what is left here? 2n plus 1 upon 3 and 1. First of all you taking what things common? n plus by 2. This is the taking common. What is left here? 2n plus 1. 2n plus 1 and bracket, and then here left only 1. So now n plus 1 by 2, taking LCM here, 2n plus 1 plus 3 upon 3. So 2n plus 2, n plus 1, here 2n plus 4 upon 3. What you take 2 common here, and then you write the answer here. 2 taking common, and n plus 1 and n plus 2 upon 3. This is your answer. This one your answer. What is your answer? N plus 1, 2n plus 2 upon 3, because this 3 and this 2 and 6, 3 to the 6, sorry, this one was 6, this one equal to 6, 2 upon 6. So you will simplify here, 2 1 is 2, 2 3 is 6, 1 by 3. So this answer will be 1 by 3 and n plus 1, 2n plus 2. According to this way you will solve the questions. Yes, note down, then next questions. Yes class, next question I am taking question number 3rd. Question number 3 here, find the sum of the n terms. Same question here, same things here. Here 3 into 1 square plus here same 2 series here. So first of all you will find the n term of the both the series. Then you will find the sum of the n terms. First of all find the nth term of the both the series. Then you will find the sum of the series. Yes, now start the question here. So Tn equal to nth term of 3, 5, 7 dash dash dash. Second 3, 5 and 7. This one second की nth term of 1 square, 2 square, 3 square dash 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 this. You will check here. The first term here 3 and common difference here 2. Then you can write here 3 plus n minus 1 2. First term here 3 or common difference here 2. Second here you will same things. How to find out the nth term of this series. So first of all you will write this nth term of 1, 2, 3 dash 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 or whole square. This square you will taking the outside. After that, first of all you will take this square in the outside. Then you will find the nth term here. Now multiply here 3 plus 2n minus 2. Same thing here. What is the first term here? 1. N minus 1. What is the common difference here? 1, 2 whole square. 2n plus 1. This is the value of the first term here. 3 minus 2 is 1. And here 1 plus n minus 1 is equal to, this will cancel here. What is this? This is value of n squared 2n plus 1. This is the value of the Tn. This is the value of the Tn of the both the series, first and second series. When you multiply here minus 1 cancel, here left only n square, you write here in this way. After that you will find the sum of the n term. Now sigma Tn equal to sum of the n term of these values. Then you can write here sigma n square 2n plus 1. Then you can write multiply here 2n cube plus n square. Then you can write here 2 sigma n cube plus sigma n square. Separating both the series. Sigma 2n cube plus sigma n square, different series. Then you will be separating. Then you add here. So first of all, sigma n 2 here. What value of the sigma n cube? n plus 1 upon 2 is a whole square. This is the value of the n cube. n plus 1 upon 2 is whole cube. This is the n here plus sigma. What is the value of this sigma n square here? So sigma n square here n plus 1 2n plus 1 upon 6. This is the value of the sigma n square. And this is the value of the sigma n cube. Now taking outside here, 2 is outside, n square n plus 1 is square upon 4 plus n plus 1 and 2n plus 1 upon 6. What things here common? Take common here first. 1 upon n You are taking common n plus 1. You are taking common upon 2. What things common here? Here 2 common. Second n plus 1 n plus 1 common. So then take it. What things left here? 2n plus 1 is left here. Plus here left only 2n plus 1 upon 3. N plus 1 taking common are 2 upon 2 3 here 6. So there are 3 left. Then you multiply here n plus 1 upon 2. Multiply inside and again taking common here. Taking multiplier 2 3 is 6. Taking whole upon 6. So 2 3 is 6. The 6n square plus 6n. When multiply 6n square plus 6n plus 2n plus 1 this way. After that you will factorize of this again. Then you will find the answer. You note down it first. Then you will take the second part of this. Yes, students. Now, but you have 2 here left. Then you will take your 2 is not taking LCM. Your LCM will be some mistake in LCM. You correct it because you have only 2 taking common. So what is left here? 2. 2 2 is 4. Or 2 3 is 6. Then you taking LCM here 6. So then you multiply here. 3 multiply 3 2 is 6. 3 you multiply here 3 and multiply 2. The 3 2 is 6 n square plus 6n. Or here multiply 2 plus 4n plus 2. Then you taking here common n plus 1 upon 6. So 6n square 6n plus 4 plus 10n plus 2 upon 6. Again taking common here 2 and here common. The n plus 1 here taking common 2 and what is left here 3n square plus 5n plus 1 upon 6 and this 2 3 is 6. This will be cancelled here. Then here not here 2 here 2. So n plus 1 and 3n square plus 5n plus 1 a whole upon 6. This is your answer. So when doing calculation you then very careful. So here something when you taking the common here the 2 is taking common we have 2 is left. So very careful here. The 2 to the power the 1 then when taking again LCM 2 3 is 6. So here multiply 3 so 6n square plus 6n and here multiply 2 so 2 to the 4n plus 4. Then you calculate it. Then you will be multiply inside taking again common here then cancellation this and then you find the correct answer. Yes, note down you. The next question. Yes, then next question I am taking question number 5th. Find the sum of the n terms 5 square plus 6 square plus 7 square equal and in this area 20 square. So then you will be here check this series here. Here this is not starting the 1 starting from 1 square plus 2 square dash 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 3 square plus dash dash 20 square. Then you can make a using the identity of the sum of the square of the n term of natural number. But here starting number is 5 or here starting number is 1. It means you will be add 1 2 3 4 left side or 1 2 3 4 will be subtract in right side. Then balance of this ratio. Now 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square dash 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 20 square. Here n term already given, not required. Don't find you the n term. On n term already given here, then you will be add here 1 2 3 4 here. Then you will be subtract also here 1 square plus 2 square plus 3 square plus 4 square. Then you will be subtracting also this here. So how to find this sequence? Now 1 plus 2 plus 3 plus 4 plus 5 plus dash 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 20. This is the whole square. This is the whole square, and same things here plus you can directly use here. Suppose you can direct sum of the square of the n terms, then you can directly use it. Don't require on this also here. You can directly use of the sigma n square, value of the n plus 1 and 2n plus 1 upon 6, and here using same thing here, sigma n. What value of the n in this series? Here n equal to 20, or here n equal to 4. In this series value of the n 20, or in this series n value of the n equal 4. So then using this here, n here 20 plus 1 and 20, 2 into 20 plus 1 upon 6 minus same here value n equal to 4. So 4 plus 1 and 2 into 4 plus 1 upon 6. Same things. Value of the n in first series is 20, or value of the n in the second series is 4. So that you can directly use this identity and find value of this series. They are 20 into 21 into 41, 12 plus 1 upon 6 minus 4 into 5 and 4 to the 819. Here 20 plus 1, this is 20 plus 1 and plus 1, 20 plus 1 21, 20 to the 40 plus 40, here 5 and 4 to the 819 upon 6, same. Then LCM number is same, then what you will take multiply and 2 times and 2 3 ja, 3 7 ja 21. Same things here, 2 2 ja 4 or 2 3 ja 6, 3 3 ja 9. What things here? 10 into 7 into 41 minus 2 into 5 into 9, 3. So 10 into 7 1 ja 7, 7 4 ja 28, 7 1 ja 7 4 28, or here 5 3 2 ja 6, 3 2 ja 6, 6 5 ja 30. And again you multiply 2870 minus 30. What is left here? 2804. So 2840. This is the what value of the n here? 20, 21. Then cancellation 2 3 is 6, 2 10 or 3 7 is 21. The 10 7 and 41 minus 4 square of the 4 here, 4 5 and 9. Then you can write here 2 2 is 4, 2 3 is 6, 3 3 is 9, 2 5 3. Then you calculate here 7 1 is 7, 7 4 is 28, as 2 4 is 0. Then you can multiply here, less 2840 your answer. Just note down it. Yes, student, next question I am taking question number 8. Find the sum of the n term of series whose nth term is given. Here series is not given, nor series given first, second, third. Here given only the nth term of the any series. Then what is the sum of the n term of this series? What is the sum of the n term of this series? Here given the tn terms. Now value of the tn here, n plus 1 and n plus 4. Then we multiply here n square plus 4n plus n plus 4. Then you multiply here n square, 4n plus 1, 5n plus 4. Again you multiply inside n cube plus 5n square plus 4n. So this is the value of the n term of the series. And anyone series here, those having the n term of this series. Then you will find the sum of this series of the n terms. Now sigma tn equal to sigma n cube plus 5n square plus 4n. Then you will doing separate this, splitting of this, then sigma n cube plus 5 sigma n square plus 4 sigma n. What value of this sigma n cube? You will putting your n plus 1 upon 2 whole square 5. What value of this sigma n square? So n plus 1 and 2n plus 1 upon 6 plus 4. And what value of this sigma n? The sigma value of the sigma n here n plus 1 upon 2. So your work is completed, but you taking the LCM, taking common and taking LCM, and then you solve it and calculate it, then you find the correct answer. So yes, what things common here? n plus 1 here, n plus 1 here, n plus 1 here. The n plus 1 upon 2. This is the common of every terms. What is left here? n plus 1 upon 2 here. Because here whole square, one side here left, one side taking outside and one side here inside. Plus what is left here? 5 upon 6 and 2n plus 1 and plus this is the common here 4. Only 4 here left. Here left only 4. Here left 5 upon 6 and 2n plus 1. And here left only 4. And here left one set of the n plus 1 upon 2. Then n plus 1 upon 2. So taking LCM here, what is the LCM here? 6. LCM of 2 and 6 and 1 here, so LCM will be 6. Then you will multiply here 3. So 3n square plus 3n. When you multiply 3, numerator and denominator, so when you multiply denominator, then 3 to just 6 or 3n square plus 3n. Here already 5, so 5 to just 10n plus 5. Or here multiply 6, so 6 4 just 24. After that, what is left here? n plus 1 upon 2, 3n square, 3n 10n 30 plus 39, or 5 plus 29 upon 6. Then you taking 6 to the 12, so n plus 1, 3n square plus 13n plus 29 upon 12. This is your answer. This is your answer. So very carefully when you taking the common here and then you calculating your calculation here. Yes, according every question you solve according. Suppose nth term of given any series, then means you will not find the n term. You will directly using the identity here. Suppose n term of this form, then multiply to correct this, then you using the identity here, then you calculate and find the answer. Yes, note down it.